Welcome to your fourth lecture with SPFD Renal Physiology. Today we're going to be going over blood pressure control and sodium balance and how the two are tied together. Tomorrow's lecture will deal with fluid balance, so this will also have a blood pressure component, but we're going to get started with some of it today. I'm sure many of you guys remember the renin, angiotensin, and aldosterone system from studying for the MCAT. So we're going to review this first, and then we're going to relate it to how it ties in with our topics here at SPFD. Let's start with a figure that you already are familiar with, and we're going to add in two parts. The macula densa within the distal renal tubule and the juxtaglomerular cells, which I will call from now on the JG cells. A key to remember is that this renal tubule is actually part of the same nephron in the diagram that we have here. This is important because individual nephrons can regulate themselves via tubuloglomerular feedback. The cells within the macula densa respond to changes in the sodium levels of that distal tubule and create a feedback loop to the afferent arteriole that supplies that same nephron. The best way to demonstrate how this system works is to work through a sample problem. We're going to start at the macula densa. This is the site of recognition of low sodium within the nephron. This whole pathway can also be triggered via renal baroreceptors in the afferent arteriole, or if there was a sympathetic tone activated. When one of these things occurs, a signal is sent to the JG cells to release renin. So, renin is an enzyme that converts angiotensinogen to angiotensin 1. This is converted to angiotensin 2 via angiotensin converting enzyme. This usually happens in the lungs, but our kidneys can do this as well. We've stated before, but angiotensin 2 is a powerful peripheral vasoconstrictor. It also constricts the efferent arteriole. Additionally, angiotensin 2 also triggers aldosterone secretion from the adrenal cortex and triggers your brain to have a sensation of thirst. All this is to fix our original problem. We want to increase our sodium uptake, increase our blood pressure, which would all make sense in a state of sympathetic activity. We will get more on this in class, but as always, reach out to me if you have any concerns or if you have any feedback to make this better, please let me know. Good luck, and I'll see you tomorrow.